I'd like to introduce Rathna Birmacheni, Director of Biopharma at KCAS Bio. So just as a short overview, highly sensitive mass spectrometers allow advanced bioanalytical labs of today to achieve LOQ required of potent biological drugs and provide maximum flexibility in choice of sample prep techniques. However, robust mass specs are crucial for several reasons: to aid in ensuring consistent quantitative performance of the assay, effectively allow the lab to meet their project timelines, and finally, they're essential for handling the inherent variability of analyzing diverse molecules and diverse samples required for bioanalysis. So with that, I'll turn it over to Rathna. Welcome, Rathna.
Hey guys, good morning. My name is Ratna. I'm the director of Bio LCMS, as Jamie introduced. At KCAS Bio, we are a CRO based in Kansas City area. The title of my talk today is Combining the Sensitivity, Robustness, and Usability of a High-End Triple Quadruple LCMS MS system and combined with SciExOS software in a high-throughput bioanalysis lab. Again, at a CRO, some of the things we are always looking for in equipment and software are that we're constantly pushing for sensitivity. What we would like to have is to be able to set up methods easily on the instruments, and also ease of transferability and reproducibility, as well as robustness when we can move these methods from one system to multiple systems. At the same time, we constantly are in need of equipment and software that can allow us to do a lot of multiplexing assays with ease. Obviously, being a CRO, it's important that we have GLP compliance for the system and softwares that we use day to day. Through knowing these different challenges we always tackle as a CRO, some of the things that we looked at when we got a chance to evaluate a SciEx 7500 plus system and a version 3.4 of the SciExOS software, we looked at does it quantitate similar to the other 7500s that we have on site today? Is it as sensitive or better? Is it robust, or how does it compare with the next gen 7500? As well as how easy is it to make methods and transfer methods across multiple instruments. As we assess this, we combined evaluating a 7500 plus prototype with looking at one of the 7500s that we have on site to compare few of these different goals that we had in mind. In order to also assess what we do, we wanted to use a case study. In this case, what we looked at is we wanted to look at a biomarker and its gene therapy product, which then gives us a certain challenges, right? So we had this project to be developed in a cynomatrix, multiple matrices from the same species, about 6 of them. And then we are also asked to look at 3 different peptides within the same method if possible. What we had to look at is a total peptide that is present both in a cynomatrix as well as human specific. And then that is specific to the gene therapy product, which is human only peptide that would be present just if the gene therapy product is present. If not, you shouldn't be seeing that peptide. And then a gene therapy derived variant. What I mean by that is with respect to the sequence that we have, there are various variants that were produced when you look at this gene therapy product that we were looking at. So there were specifically 3 different ones. So we are in need to do a multiplexing assay in this case, but also develop methods across 6 different matrices. So it's a complex assay, but then the other ask is that we need to develop these assays with low nanogram per ml sensitivity. Same thing, we are needing to qualify this assay to be able to run 1800 samples in a 4-week time period, which means we needed to keep going and we cannot afford any system downtime through this whole process. So this is the project that we used as a case study. As we look through this project, I want to give a little bit of a background on what this does is we looked at 3 different peptides specifically. In this case, the EBV peptide is a common peptide that we used to quantitate both the cyno and human peptide together. And then we were looking at LPA peptide, that is human specific, that should be only present in the gene therapy product in cyno background. And then you would have the CLR peptide. In this case, this is a variant where some of these amino acids at the N-terminal are missing in some variants versus the others. So we needed to figure out of the 3 variants that we were expecting to see, which one is the most dominant, and also if we can qualitatively monitor the other 2. So little bit digging deeper into this project, we ended up having to develop 2 different methods because of the type of peptides that we have on hand and the uniqueness of these different delta variants that we needed to go after. So for method 1, we ended up having to do a immunoprecipitation LCMS assay with trypsin enzyme as the enzyme of choice to be able to pick up the EVV peptide, which is the total, LPA peptide, that is the human specific. For method 2, we picked up all the 3 variants. As you can see, variant number 2 here is much more dominant in comparison with the other 2 variants. So for this purpose, we use the same IP method in the front end, but post IP, we had to use, instead of trypsin, we had to use a lyc enzyme to be able to pick up these 3 different peptides. For all of these samples that were processed, these were needing to be again processed in 6 different matrices within the cyno species, and we had to run a total of over 1800 samples for both of these methods here. So again, monitoring 5 different peptides and quantitating 3 of them as we move forward. A little bit of a background into hybrid LCMS here. So what we did in this case is, again, those of you who have some background on hybrid LCMS can understand that there are various ways of doing this first step here. In this case, what we did was use what's called a bucket method, where we incubated the unknown sample with the biotin-related antibody and streptavidin-coated magnetic beads. Once the antigen-antibody complex is formed, we were able to wash off the unbound samples as well as other non-specific interactions, and did an acid elution into a fresh plate where we have released this analyte of choice. We then subjected it to reduction alkylation step and then digested it, whether it by method 1 or method 2, to showcase the different peptides that we are going after. Again, for this analysis, we used the SciEx 7500 plus prototype to be able to analyze these samples that are being extracted from the 6 different matrices, as well as monitoring multiple peptides in this case. So I just wanted to show a little bit of a representation of the kind of data that we got. I also wanted to focus on just the 2 matrices for ease of upkeep with showcasing the data. In this case, we have a standard curve. Again, typically we run a curve on the top of the batch and a curve at the bottom of the batch. So these are the percent CVs and percent accuracies. The curve fit was shown. For this slide, we are also again showing the EVV peptide, which represents the total protein of this endogenous biomarker as well as the gene therapy product. These are some of the QCs that we were able to gather data for, where you see the percent CV and percent accuracies, and the LLOQ in the surrogate matrix. Since this is a biomarker, again, we couldn't use the matrix for the curve. We had to use a surrogate matrix. These are the brain QCs, again at a low QC level. The sensitivity at the low QC level is shown here. On the left-hand side here are the different QCs at the basal level, low and high QCs, as well as the different dilution QCs that we were showing. This data set here includes, again, data from the cyno serum, as well as the low QC that is being shown for this cyno serum QCs. Again, the percent CVs and percent accuracies are shown here. In this case, we are looking at human-specific peptide. Similar to what I've shown in the previous slide, your curve fit, percent precision and accuracy for the curve, as well as QCs, including surrogate matrix, brain, and serum. The sensitivity here is a little bit lower. Again, is a little bit variable between the type of matrix that you're looking at as well. The low QC value is highlighted here qualitatively for you to see for a chromatogram. The third slide here is again the precision accuracy data with again N of 2 different matrices alongside the surrogate matrix shown in cyno, brain, and serum. And then we have the LLOQ for in the surrogate matrix and low QC values that you can see in brain and serum. Again, this is one of those peptides that didn't have a good ionizability to begin with to get as low as we can. So having a very sensitive instrument on hand really helped to be able to get a LLOQ that is in the low nanogram per ml, just like the way the client was looking for. This is a slide here showing the sensitivity of 3 peptides, EVV that represents the total part, LPA that represents the human specific part, and the variant, again, specifically variant number 2, that is the most dominant one of all these variants. Again, from left to right here, we have the surrogate matrix and the cyno-brain and cyno-serum matrices. Again, EVV should have some basal presence. So if you're seeing a peak in the blue, which is supposed to be the blank, it is again expected because it's endogenously present. And then you have the LPA, that is human-specific peptide. You can see it once you move into this matrix lots. Again, chromatography is important, and timeline is something that we needed to keep up with. So we did the best we could to be able to separate it enough to be able to also see the LLOQ or the low value that we are looking for. Same thing with the variant. As you can see, once you move into the matrix, the sensitivity here is less because of the extraction efficiencies that we had in these different matrices. In this case, we did have a small peak in the background that we needed to subtract to be able to quantitate this peak to be able to give us the relevant data for the CLR variant 2 in cyno-serum. Similarly, we did a comparison between SciEx 7500 and SciEx 7500 Plus. We used a total peptide, which is EVV, as a comparator to look at sensitivity against both of these instruments. So in this case, yes, the signal to noise ratio that you see is showing that maybe the 7500 plus has a little bit better sensitivity. But again, it's important to understand that at this point in time, we were comparing 17500 plus with 17500 that is present on site. We have over 13 of the 7500s on site. So it just shows us at this point, we can conclude that maybe the sensitivities are much more comparable with each other than not when you look at this data here. So then in this case, we compared the sensitivity across different matrices as well and compared it with SciEx 7500 and 7500 plus together, showing the Sigmatrix, CSF, serum, brain, and liver from cyno species. What you will see is that the data is very comparable with each other across the board, across the multiple matrices that we were testing here. And this is again a representation of a curve fit that we were able to gather from a SciEx 7500 and a SciEx 7500 plus, using again the total EVV peptide as a reference. What you will notice is that the curve fit as well as the R-square value that you're seeing is very comparable to each other. What we were able to do through testing the different parts of evaluating the SciEx 7500 plus, as well as comparing it to the current 7500s that we have on site, we were able to show that 7500 plus was very reliable to be able to run multiple complex matrices that were extracted with respect to this particular study. And we were able to monitor multiple peptides with high throughput again and again. We ended up being able to run over 5,100 injections with minimal to no maintenance in the last 5 months. We have been monitoring system suitabilities, PepCals, top of the batch and bottom of the batch as we went through this evaluation process. Through this, as we are running our samples, we have been injecting high sample volume to push the sensitivity to have it at that low nanogram per ml. In this case, we were injecting anywhere between 75 to 150 microliters of injection volume per sample through these 5,100 injections that we did. This is a representation of how the system have been performing. What we did in this case is that those system suitabilities that we run, we use what's called a PepCal mix, which consists of 20 different peptides that gives that are eluting at different retention times for us. As a representation, we picked one of those 20 peptides, ALE peptide, and then plotted it over time. So on the x-axis that you see the number of injections, on the y-axis you see the response over time. So what this shows us is that through and through those over 5,000 injections, the sensitivity of this instrument have not been going down. We were able to gather the data that we needed for all the different peptides for both quantitative and qualitative purposes. And one thing to note here is typically in a CRO lab like ours, we prepare these PepCal mixes. We do not prepare them fresh on the day of. Typically, we prepare them and keep it for about a month to be able to evaluate the system performance over time. So that's the other thing that we do want to take into account to be able to assess this particular graph here. Keeping in view of that previous graph that we are looking at, I was then able to look at the different IS responses between those 5,100 injections that we did. So we were able to gather some data and do a IS metric plot showing the data in between this 200 to 500 injections for 2,800 to 2,900 injections, and then between 3,300 to 3,450 injections. What you see generally is sometimes it takes some equilibration time to get up to speed, but overall, with respect to the response over time, we were able to again gain insights into the project that we are working with. The system performed very consistently, and we didn't have to have any sort of cleaning done for this instrument through this whole process and injection of this particular assay. With that, I kind of want to shift gears to move into assessing the SciExOS software and some of its features as we use it for our utilization day to day. What we were able to look at is that we looked at the custom formula space in the software. Again, because of the kind of project that we are working with, we needed to look for basal levels and calculate those QCs that were spiked on top of the basal level. So these biomarker calculation spike formulas were very important, that were easy for a user like us to be able to put together and use it. And the data is right there on the SciExOS software for us to be able to look at. So that is one thing that we evaluated. The second one is the types of different algorithms that we have. When you go back to look at that chromatography, you will see there is a lot of background. Sometimes it's easier to use a auto-peak algorithm versus a multi-quant algorithm to be able to assess or get a good area under the curve for us to be able to put together those statistics. So in those scenarios, having those choices for 3 different algorithms was very useful for us. And then, as I was speaking before, we had at least 5 different peptides to look at, but minimally 3 of them to quantitate. Similarly, we also use 20 different peptides for system suitability across the board day to day. So it is important for us to have a software where multiplexing quantitation is made easy and fast, so that we can keep up with our day-to-day activities. The other thing that was quite interesting with this particular version of the software too is to be able to use the metrics tracker to monitor the instrument performance over time. What this means is that because we leverage system suitabilities from PepCals, it's easier for us to go through how the system has been performing over a period of, let's say, 6 months, to be able to understand what kind of system downtime we had, to how much we were able to take advantage of this equipment over a period of 6 months, to calculate the return of investment on this equipment. For the first one, with the SciExOS software, we have, again, custom formulas and ease of integration. Over here, we generally looked at different parts of the software, we were able to make some custom calculations put together and label them the way we would understand it. At the bottom here, again, an example of that calculation that we were able to put together. And on the right-hand side, we were able to show the integration algorithms that were available and what we were able to see. This is, again, some data that I was able to put together, showing you the different special tabs that you can create based on those custom formulas that we put together. In this case, as an example, we are showing the basal level of what it is, and then the spiked concentrations of what it should have theoretically been, and it back calculates the values to show a low QC and the high QC levels for this brain QCs here. Here is an example of efficiency in multiplexing. In this case, I took the PepCals that we run on the top and the bottom of the batch as an example. Again, here there is a N of 20 different PepCals to be able to easily integrate area under the curves for all of these different peptides and be able to come up with some statistics. It was incredibly easy to put that together, and at the tap of a button, we were able to utilize some of these different parts of the software to be able to get the data that we needed. This is, again, an example of the metrics tracker that I was talking about. Again, this is present in the newer version of the SciXOS software that we were looking at. What this does is, just to orient you guys, you have your x-axis with the timeline of when these system suitabilities were run. On the y-axis is your areas of these different peptides that we are monitoring. In this case, again, for the ease of representation, we are looking at ALE peptide as a part of that PepCal mix, and the different spread of when these PepCals were run. So when you zoom into one part of this PepCal set that we are looking at, it then spreads it out horizontally to be able to give you a good idea of what the PepCal responses are over a period of time. Again, potential improvement that can be done here is it can then have a click button around the area where we monitor these during acquisition. That would help us easily being integratable to be able to view this data easily as well. But so far, I think having this is really helping us monitor the system's performance over a period of time. So in conclusion, what we were able to look at and achieve is that we were able to achieve the needed LLOQ for 2 of the peptides that we were going after. We were able to look at 0.49 nanograms per ml, and for the variant 2 peptide, we were looking at 0.98 nanograms per ml as an LLOQ. That was the best that we were able to achieve as we pushed through the sensitivity. We were able to qualify all the 6 matrices that we are going after in cyno species. We post qualifications of these 3 peptides in the 6 different matrices. We were able to run over 1,800 samples back to back without any system downtime. We were able to consistently achieve reliable and dependent data because of the usage of this new software that we adopted. We were able to cut down the time for processing for the multiplexing assays. We were able to generate data for both the 3 quantitative peptides as well as the 2 qualitative peptides. Again, these different software features that we were able to use to report the basal values easily, and we were able to use it with minimal change from type to type that we were going after it, and with minimal formatting as well. Currently, we have about, I would say, 13 7500s in-house, and we flex between them every day, change it up as at a CRO, we typically cannot have one system set aside for a project. Normally, things keep moving around, and that's something that we had to keep up with and do typically. So I feel like when we moved from system to system of a 7500 to 7500 plus, we were able to get, again, ease of transfer and reliability in the data that we were able to gather for this particular project. Again, we just purchased 3 7500 plus instruments that are being set up in the lab. We are continuing to evaluate this prototype of SciX 7500 Plus for both the hardware portion and the software portion of the equipment here. With that being said, I cannot obviously get this data together without the amazing team that I have. So I want to thank them for being able to help me put something like this together. And thank you.